let us start. So let us prove if the function is differentiable then it is continuous. Then we'll see why it is not true. Converse is not true. Continuity does not imply. We are doing in scalar field, so let us do that. Let us write the statement. If a scalar field f is differentiable at E, then f is continuous at A. Okay. Proof is one line proof. You already know. You have what you have to do. Correct. So think about consideration part. You will able to understand that. Consideration part क्या रहेगा? Let me leave some space and talk about consideration part. You have to talk about f of e plus h minus f of e. Correct. This should be less than epsilon. But here we are having one more guy. That is we are having a t of h. Na? So you'll add and subtract t of h. That is f of e plus h minus f of e minus t of h plus t of h. Correct. That means what if you use triangle inequality, it will be f of e plus h minus f of e minus t of h and plus it will be mod t of h. Okay. So what you want to have? You want to have this as epsilon by 2. This also have to be epsilon by 2. Then you will able to prove. Correct. That is the main idea. So let us see how can we if we want to make this as epsilon by 2 and this also as epsilon by 2. Correct. That was the main idea. So once you are having idea, let us start. So you are given with something. F is differentiable. Correct. Differentiable at A. What do you mean by that? For all epsilon positive, there exists delta 1 positive such that norm of h that is less than delta 1 implies what? F of e plus h minus f of e minus t of h upon norm h that is less than epsilon by 2. I'm writing. That means what? Mod of f of e plus h minus f of e minus t of h that is less than norm h into f1 by 2. Okay. Yes. So we have got the first part. What is the next thing we want? Yes, what is the next thing? Next thing, as per the condition we have seen, we have got a condition for this guy. We want condition from what t of h. But do we know something about t of h? Where what is t? T is a linear transformation. Linear transformation. And I think in the last exercise I proved that every linear transformation is continuous. That means what? This is continuous. If it is continuous, then can I write the definition of continuous? For the same epsilon positive, there will exist delta 2 positive such that norm of h that is less than delta 2, that should imply t of e plus h minus t of e that should be less than epsilon by 2. But I want the condition on t of h. But t is a linear transformation, so can I write it as t of e plus t of h minus t of e that is less than epsilon by 2. So this is gone. So what we are having? We are having t of h that is less than epsilon by 2. What else now? I try to see. We are having condition on both the guy. First one is this, second one is this. So now we have to choose a delta which should work for everybody, correct? So see, the problem is that here I am having norm h also, correct? So norm h is already less than delta, so I want this guy to be 1. So for choosing delta, let delta must be minimum of 3 value. Minimum of delta 1 delta 2 and 1. If I am considering this, then I'll be having this one, that is mod of f of e plus h minus f of e minus t of h, that will be less than norm h epsilon by 2, but norm h is minimum of this, so this will be less than epsilon by 2. Agreed? And same happens with the second guy. This is already 2, that is mod of t of h, that is less than epsilon by 2. So can I use it here now? Can I use it here? This guy is less than epsilon by 2. This guy is also less than epsilon 2. That is equal to epsilon. That means what? F of e plus h minus f of e, that is less than epsilon. What does this imply? Function is continuous. Correct? And a. So what did you prove? You started with your function as differential function and you proved it in a continuous function. Correct? Now the next question will be, what about converse? I'll write remark converse of above theorem is not true. That means I need to give a function. So I'll give this function. Sorry. F of x y equal to root of x square plus y square. This function is continuous at 0 0, but not differentiable. Continuity is easy to prove here. This is a polynomial only. So I'll have to prove this is not differentiable. But I'll prove this with the following theorem. To prove this is not differential, I am lack of something. So let us see. So as you know that I started with saying that we have known about total derivative, correct? And I want to relate with your directional derivative and partial derivative. So what is that next theorem says? If your function is differentiable, then its total derivative exists in all directions. Sorry, its directional derivative exists in all directions. That means what? Differentiable implies directional derivative exists in all direction. What do you mean by in all direction? That means what? Can I say that partial derivative also exists? Because अगर standard even e2 को vector लिया मैंने, so that will give me partial derivative. That is the special case of directional derivative. That means what? When your function is differentiable, then directional derivative भी exist होना चाहिए, partial derivative भी exist होना चाहिए, correct? So to prove not differentiable, we must need to give a vector where the function is not differentiable. That's it. Okay. So let us see. Let us write the statement first. What do you want to prove? We want to prove differentiability implies existence of directional derivative. Differentiability implies directional derivatives. Okay. I'll write the statement. Let S be a non-empty open subset of Rn. Let the function f s to r be differentiable at a point E belongs to S. Okay. Then for every non-zero unit vector, for every non-zero unit vector u belongs to Rn, the directional derivative du f of a exists in direction u, and directional derivative of f of a is given by df of e at u. That means what? T of u. Correct? This is what you want to prove. Let us go through the statement once again. Try to see. You see that at the place of h1 h2 I am having that. So let us start. Correct? What do you want to show? To show du of f of a that is same as t of u. Correct? And what is the formula for du of f of a? Yes? Do you remember the formula for du of f of a? Directional derivative का formula. Limit h tending to 0. Sorry, t tending to 0 we were using there. Limit t tending to 0. It was f of e plus tu minus f of a upon t. Correct? This was the definition of directional derivative. If you remember, where u is a unit vector. Unit vector is तो non-zero भी है, so that is not an issue for me. Okay. If you want to write epsilon delta definition, then also you can do. That means for all epsilon positive, to find delta. To find delta positive such that mod of t is less than delta, it should imply mod of f of e plus tu minus f of e upon t minus tu. Correct? Maybe right. Mod of f of e plus tu minus f of e upon t minus tu. T of e, that should be less than epsilon. This is what I want to prove. I want to find a delta. Correct? But what we are given अभी तक वो use नहीं किया हम लोगों ने. Correct? We are given with something. What we are given? F is differentiable. F is differentiable at e belongs to s. What do you mean by that? What is the definition of derivative? That is, for epsilon positive, there exists a delta positive such that mod of h that is less than delta. This should imply what? Mod of f of e plus h minus f of e minus t of h divided by norm h. That will be less than epsilon. Correct? Now try to see इधर भी ऐसा ही कुछ है, but at the place of h. You see, at the place of tu I am having h. So can I substitute? Can I substitute? That is, let h equal to tu. If I put h equal to tu, where t is any real number, then what will be norm h? Norm h will be same as norm of tu. That means what? It will be mod t. T is a real number. And norm u. U is a unit vector, norm u is 1. So this will be mod t. That is less than delta, which we are already having. That means what? The above condition will be f of e plus tu minus f of e minus t of tu. Because at the place of h I am putting, it will be t of tu and divided by norm tu. That is less than epsilon. So can I solve it little bit? What will be t of t? Since t is a linear transform, I can take t common. So I will be having what? This is f of e plus tu minus f of a minus it will be t times t of u and divided by what will be this? This will be mod t. Correct? That is less than epsilon. What do you mean by that? This means that f of e plus tu minus f of a upon t मॉड के अंदर रखा तो देयर इज नॉट एन इशू. माइनस टी ऑफ यू दैट इज लेस देन एप्सिलॉन फॉर द सेम डेल्टा जो उसके लिए काम किया था. दैट मीन्स व्हाट, du of f of a that is equal to t of u. That means directional derivative is same as t of u. You see that? So, oh, I'm sorry, what is happening? So what did I prove? I proved something beautiful, that is, if your function is differentiable, then the directional derivative exists. And what are the partial derivatives? If you put u as ei, then it will give partial derivative do f at do xi. Correct? That means what? Differentiability implies existence of directional derivative. Directional derivative. That implies existence of partial derivatives. That means what? If your function is, if it does not have any partial derivative, then you can say that is not differentiable. Or if a function is not differentiable at a vector, or it does not have directional derivative, then it is not differentiable. I'll just quickly write a note, or you can write a theorem or corollary. Corollary: let S be a non-empty open subset of Rn. Rn and f from S to R be differentiable. Okay, this is differentiable. Then each of the partial derivative, that is do x e at do xi, exist for I equal to 1 to up to n. Correct? That is, each of the partial derivative exist. Proof is easy. Okay. Trying to connect it. Let us do one problem, that is evaluate directional derivative. Derivative of function f of xy, which is equal to x square plus y square at this point 1 comma minus 1, in the direction minus 3i plus 2j using total derivative. सी हम लोग ने डायरेक्शनल डेरिवेटिव डायरेक्ट फाइंड आउट करने का मेथड देखा है. Now we have to find directional derivative using total derivative. That means first we need to find total derivative. How will you find total derivative? The function is this. Can you quickly tell me what is total derivative? Anybody? This is your function. So what will you do? A is given. A is 1 comma minus 1. What is h? H1, H2. How will you find total derivative? What is v plus h? I think ये क्वेश्चन का हम लोग ने टोटल डेरिवेटिव फाइंड आउट किया है. Maybe I'll do it again, no issue. आई थिंक हम लोगों ने इसका टोटल डेरिवेटिव फाइंड आउट किया. यू जस्ट चेक You'll see. So what is f of e plus h? It will be 1 plus h1 the whole square, and this will be minus 1 plus h2 the whole square, correct? So what is that? क्या आएगा ये 1 plus 2h1 plus h1 square, और इधर क्या आएगा? It is again 1 plus it will be minus, no? Minus 2h2 plus h2 square, correct? This is f of e plus h. So I have to calculate e plus h minus f of a. If you take minus f of a, so f of a क्या आएगा? Will be 1 and 1. So ये दोनों cancel होंगे 1 1. I'll be having only 2h1 plus h1 square minus 2h2 plus h2 square. Can you tell me what should I choose my t of h? Anybody? Define t of h1 h2. Anyone, can you tell me what should I choose out of this thing? T of h क्या रहेगा? I already told you T of h1 h2 will be of the form EH1 plus BH2. That's it. So what will be that? It will be 2H1 minus 2H2, correct? The next part I leave that exercise, that verify this is your total derivative. Okay, suppose I am having total derivative. So you know that what is directional derivative? As per the previous theorem, directional derivative at du of f of e, it will be t of u. बट पहले उसको u तो बनाना पड़ेगा ना, दैट इज यूनिट वेक्टर बनाना पड़ेगा. द वेक्टर गिवन टू अस इज -3 and 2. So -3i plus 2j divide by what? Square root of 9 plus 4. That means what? 13. So it will be -3 by root 13 plus 2 by root 13. This is I j. So this is u. You just have to calculate t of u. That means what? T of h क्या है अपना? T of h is equal to 2h1 minus 2h2. Just you need to put it here. That means 2 into minus 3 upon root 13 minus 2 upon 2 root 13, correct? Just solve it. क्या आएगा ये? Minus 6 minus 4, that will be minus 10. Minus 10 upon root 13. Correct. So this is your directional derivative at that point. So do you see that directional derivative हम लोग ने कैसे find out किया? Using this, using total derivative. Now but the next thing is हम लोग ने ये theorem proof क्या किया था? What was our motto? Our motto was to prove that every continuous need not be differentiable. So we give that example, f of x equal to x square plus y square. Now we will prove that. Prove that f of x comma y, that is equal to square root of x square plus y square, is not differentiable at 0 0. So this you want to prove this. How will you do? What I will do, if suppose if f is differentiable at 0 0, then implies what? All the directional derivative exist. Derivative must exist along every u belongs to R. You take any u, all the direction derivative exist. We'll prove that this does not happen for some u. Let us take let u equal to, I am taking 1 comma 0. This is a unit vector, correct? And can you calculate directional derivative? See, u equal to 1 comma, that is partial derivative if you see, correct? So that means du of f of a, that is what? Dou f by dou x at 0 0, correct? That is partial derivative. Agar u 1 0 लिया, this is even, if you remember. That means we are going to see that this partial derivative does not exist. Let us see. What is the formula for partial derivative? Do you remember? It is limit t tending to 0, f of 0 plus t comma 0 minus f of 0 0 upon t. करेक्ट. अगर यही with respect to y किया होता तो this was 0 comma t were here. Now let us see क्या आएगा ये. This will be square root of t square. That is limit t tending to 0, it will be square root of t square plus 0 minus 0 upon t. That means what? Limit t tending to 0. What is root of t square? Yes, root of t square is mod t upon t. Now you see this limit, if I take limit t tending to 0 plus, then this will be 1. This will be t upon t, that is 1. If I take limit t tending to 0 minus, then this will be minus t upon t, that is minus 1. So limit at t is not x0, it does not exist. That means what? Dou f by dou x at 0 0 does not exist. That means what? Du of f of 0 0 does not exist. What is the conclusion? If this does not exist, that means what? F cannot be differentiable. Differentiable at 0 0. Correct? So what did we prove? इसका ये फंक्शन का पार्शियल डेरिवेटिव विथ रिस्पेक्ट टू एक्स डज नॉट एग्जिस्ट. सिमिलरली यू कुड हैव डन विथ रिस्पेक्ट टू वाई ऑल्सो, तो उसमें भी यही आता है. Do you understand that? Okay. Now you must ask, sir, is there any sufficient condition which can tell me that function is differentiable, then this is true, and this is true, then it is differentiable, something like that. Because in this case, the partial derivative does not exist. But there may be a function where partial derivative exists, but still function is not differentiable. That means this we're having some time. Okay. Now, so I'll just give one exercise for you. Let f of x comma y equal to 2xy upon x square plus y square. Okay, and where x comma y is not equal to 0 0, and it is 0 when x comma y equal to 0. Okay, show that show that dou f by dou x and dou f by dou y exists at 0 0, but f is not differentiable. F is not differentiable at 0 0. This is your homework for next lecture. Do that. We'll see one more sufficient condition. Do you see in the previous case that partial derivative does not exist, correct? But here they exist, but still your function is not differentiable. So we want a sufficient condition which can tell me that differentiability implies this and that implies that, correct? That is what next thing is.